Alrighty, CNT125, Chapter 8. We're now going to look at variable length subnet mask, VLSM. Now, just as a real quick heads up, we're going to introduce the topic here and kind of put it in the back of our brain. This is something you're going to work with more in 220, or next networking class. So we're going to at least get the ball rolling that you understand the concept. That's something you'll apply more in 220. Okay, with traditional subnetting, we do actually have a waste of IP addresses. When I take my IP address pool and break them up into pieces, you notice I'm losing the network number and the broadcast number, and I'm also going to have wasted IPs in there that don't get used. It's kind of like cutting up a pie in equal pieces. When I pull the pie out, there's always crumbs left in the pan. That's the waste. The other part about this too is, when I cut up a pie in equal sized pieces, inevitably somebody's like, well, I wanted a piece smaller than that, or I wanted a piece larger than that. It's really tough to take and cut a pie in 8 equal pieces and then start cutting some of them in half, or some start making them larger. It's really tough to do that. The same thing is true with traditional subnetting. When you break in traditional subnetting, it's equal pieces of 8 equal pieces, or 16 equal pieces, or so forth. That's all it can do. With variable length subnet mask, I can actually create subnets that are of different size. Now, there's some limitations on what you can do, but I could create one large subnet, and then from the second subnet, I can create a bunch of smaller subnets. So I can break it down further inside of a subnet. So that's why sometimes they call this actually subnetting a subnet. All right. To do this, I start off by saying, okay, what does my largest subnet need to be? What's the next largest subnet to be? What's the next largest subnet need to be, and so forth. So the book uses an example where they have, 192.168.10 IP address space they're going to use, and they know that these different departments need roughly these number of hosts, 120, 58, 25, so forth. So they take a chart and say, okay, let's rank order them. Largest up top, smallest on bottom. Because what happens is you carve out a big subnet here, then a smaller one here, then a smaller one here, and a smaller one here, and so forth, and work your way down. That's what you do. Again, kind of like cutting a pizza. You cut the big piece first, then you take what's left and you start calling some smaller pieces, then smaller pieces, and so forth. Okay, that's how it gets done. So here's the example. They give it to you in just kind of words, but they don't show it to you, so I kind of broke it out to try to show you a little bit. So the first subnet, they say, okay, we need about 120 things hooked up. So I take my last octet, borrow 1 bit. When I borrow 1 bit, 2 to the 1 is going to give me 2 subnets. So the first subnet is about 128 numbers big. That's going to accommodate this group of workstations here. The other subnet, subnet 2, we're going to leave, and we're eventually going to take that space, as I see here, and divide it further into these little pieces. So I have the first 2 subnets, and I'm going to actually use the first one. The second one I'm going to hold on to, because I'm going to take that and break it into further pieces. And I'll use a /25 for that subnet right there. Okay, the /25 means I can use those first 128 numbers for the sales department. Okay, so now I take that remaining piece starting at 128, and I'm going to then take this and borrow 1 more bit, so /26 now, and I'm going to create 2 more subnets. So I'm taking the 128 to 256 and breaking it into 2 pieces. So 128 to 191, 192 to 255. I'm breaking that into 2 pieces. And this second piece, that is 128 to 191, that's what, about 64 numbers there, somewhere in that ballpark. That's going to accommodate this subnet right here. And this third subnet we're not going to use, we're going to hold on to for these guys here. Okay. Next one, I take that space and I break it and I borrow 1 more bit, so I'm up to /27, and I take that 1 piece that I had before and break it into 2 more pieces. So now the 192 to 255 gets broken into 2 pieces. We're now at pieces of 32. 120, 64, 30, yeah, pieces of 32. So now pieces of 32, that'll accommodate this guy right here, this department of 25 computers with a couple left over. So that third one gets used, the fourth one gets set aside and hold on to the remaining 32 numbers, if you will. Okay, so now I take and I'm going to borrow 2 more bits. So those last 32 numbers I borrow 2 bits, and that's going to break it even further. It's going to make 4 subnets out of it. So I'm going to break that into 4 pieces. So now I'm going to go by 8s. And those 8s, as I see here, 224, 232, 240, 248, going up by 8s, I now have 4 pieces of 8. So this takes care of 4 and 5 right here, because those were just shy of 8. Okay, these 2 subnets are going to get used for them at a /29. These 2 last subnets we're going to hold on to, the 6 and 7. We're going to hold on to them. I'm then going to, with that one, I'm going to take and borrow 1 more bit. When I do that, I get 2 more subnets. In this case, we're now up to pieces of 4. And I only need 2 numbers here. So a piece of 4, 2 of them not going to get used. That's perfect. I have it for my WAN links. I now have subnet 6 and 7 for my 2 WAN links. And I do have a little piece left over now. I have a /29, so I have a chunk of 8 numbers left over that could get used for something else down the road. That's remaining space. That is how VLSM works. I start by doing the rank order of my subnets, work my way from highest to smallest, and I subnet, take what's left over, take the leftover, subnet again, take what's left over, subnet again, and I just start working my way down the line, just taking good record keeping. So here is what they showed, the departments and the breakdowns, and they showed a little graphical representation of there's the sales, counting, HR, and I'm just going smaller and smaller and smaller to accommodate each of the areas of my network. And they did mention this was a little bit tight on subnetting. You would never do it that tight, that is correct, but it gives you a really good visual example of how you would do variable length subnet mask, VLSM. Again, this is a good concept to get introduced to you now. 220 is the time when you're actually going to use this.